A few things I want to talk about here on our paper. So first of all, these first three properties, okay, that we are going to be dealing with, we're going to be using these a lot in geometry. These are some like geometry properties that we're going to be using. I think, yes, okay. So many of these properties you've used before. For example, all right, the addition, subtraction, multiplication, and division property of equality. All of these properties, okay, these are ones, the properties that are kind of like that whole do the same thing to each side. And you don't have to write this down if you don't have to write this down if you don't want to. Do the same thing to each side, right? That's kind of like, these are these properties that when you have an equation, you know that you're allowed to like add, and I'll zoom in on that because you can barely see that. When you have an equation, you know that you're allowed to add the same thing to both sides, or subtract the same thing from both sides, or multiply the same thing to both sides, or divide the same thing to both sides, right? That's all stuff that you have used since, at least algebra, maybe even before that. These first three, though, these are kind of like newer to geometry, okay? These are ones that we're going to focus on using in geometry. So you maybe have used these before, but these are going to be heavily used and more heavily used in geometry. Specifically, we're going to need to know these three. I'd be able to identify them, okay? So reflexive property is the easiest one to kind of identify, right? Think of the word reflection, right? When you look in the mirror, you see yourself, right? So A, right, is equal to itself. Something equals itself. So, 2 equals 2, that's the reflexive property, okay? A equals A, that's the reflexive property. X equals X, that's the reflexive property, okay? Symmetric property, okay, right? We could talk about this some here now too. Symmetric property, if A equals B, then B equals A. And of course, some of you guys are like, well, duh, Mr. Whitmire, that's like always true, right? If A equals B, then B equals A. You can flip around, an equation and stuff. And then transitive property, this one probably, is the more complex of them, but it's not that bad. It's just if A is equal to B, but B is also equal to C, well, then what must be true about A and C? They must be equal as well, right? So if A equals something, but that same something is also equal to C, well, then A and C must also be equal, okay? These kind of like two equations join together because they both have B in them, and so therefore A and C must also be equal as well because the B's are equal to them, okay? That's the idea there. So those are those kind of explained. So now what we're going to do is going to take a quick look at how we use these. All right, so if you go to the next page, page 47, okay, in your books there, just the very next page from page 46, page 47 here. Okay, you look at the top, you'll see how we're going to maybe use these somewhat here, okay? So for example, in letter A here, you can see that we've got an equation. All right, and we're just going to basically use these properties here to kind of show what's happening in this equation. So they just rewrote the equation here, 14 equals 3x minus 4. And then in the next step here, the equation's now changed. Okay, can someone raise your hand and tell me what happened from this first step down to the second step here? Yeah, Corey, go ahead. Yeah, added 4 to both sides. And if you look, and they don't have, they don't show the little plus 4 here that we might show for our work. But if you look, over here it says addition property of equality because they added the same thing to both sides, right? They added 4 to both sides to get to here. Okay? And now from 18 equals 3x, they went down to 6 equals x. All right? So someone want to raise your hand and tell me what property was that? So, Debbie. Division, right? I mean, if you look here, right, they took 18 equals 3x, and now it's 6 equals x. So they divided both sides by 3. Again, you guys know that you need to divide both sides by 3 here, but maybe you didn't know that you were using the division property of equality. Okay? And then the last step here, they go from 6 equals x to x equals 6. All right? So they just flipped it around, right, and that's the symmetric property. If 6 is equal to x, then x is equal to 6. And again, most of you guys, probably, you don't bother writing the 6 equals x step part. You just go from here straight down to x equals 6. You'd flip it on your own. Okay? So now if we look at this next one here, letter B, there's some blanks for us to kind of fill in, all right? And I'm not always a big fan of the blanks, but in this case, I think we'll fill in these blanks here on our own. I think we should be okay. All right, so we have 9 equals 17 minus 4x, and so they just rewrite the equation here. All right, and then the next step, we go from 9 equals 17 minus 4x down to here. 17 here has disappeared, and so something is changing here. So let's see here. Addie, can you tell what's happening from this step to this step? What's changing? What they do to kind of both sides of the equation here? Yeah, what did they subtract? Yes, exactly right. Subtract 17 from both sides here. And so 9 take away 17 is negative 8, I think. Okay. And so then what property did we just use there? Yeah, subtraction property. Okay, that's right, subtraction property. All right. Very good. All right, let's see. Next step here, let's go to... All right, so the next step now, we're going negative 8 equals negative 4x. And I think that's just, I think that's a typo. That should not be there, I don't think. Okay, because there's no property there listed. So we're going to skip from this one down to this one. I'm pretty sure that's a typo there. And that's another thing we're going to come across here is that this book is still has some typos because it's pretty new. So, all right, so we're going to skip from here down to here. All right, Alex, can you tell me what's changing from this step down to this step? What are they doing to both sides there? Okay, go ahead.
Oh, okay, I mean, they're dividing it?
Yeah, dividing both sides by what? Negative 4. But yeah, exactly right. Yeah, it's negative 4x, and that's changing to just a regular old x. Well, how would you do that? You'd have to divide both sides by negative 4. You're exactly right. And so we're going to divide both sides by negative 4. Negative 8 divided by negative 4? 2. So what property do we use there that allows us to divide both sides by the same thing? Alex, what was that? Yeah, division property. You got it. Exactly right. Okay. Now, right now we have 2 equals x, and then you'll notice it now switches to x equals blank. And so what should go in that blank? Let's go to Zach. What should fill in this? What should go in this blank here? Okay, sorry. So again, we have 2 equals x, and then it switches to x equals. What should this be? What do you think it should be? It was, so again, I'm sorry, there's no, look, if you look here, the x is not changing. The only thing that's changing is where x's place is. X was on the right, now it's on the left, so what do you think should go here? Yeah, just 2. It's the same thing. We just flipped it around, okay? Now, which property allows us to flip it around here, if you want to look back? We just talked about it. It's one of our new geometry properties. Which of these geometry properties allows us to flip the equation around? Symmetric property, exactly right. So we're using the symmetric property. Okay? So that's the idea there, symmetric property. Okay. Questions on any of those? So that's you know, something we need to be able to identify those properties, and we need to be able to you know, kind of see them where they are in the work here and stuff. So let's jump down here. We're actually going to come back to these in a little bit. Okay, we're going to come back to these in a little bit, but right now I want you to jump down to here. Okay, and we're going to identify the property of equality that is used in each statement. So we're going to identify the property here that we're using. Okay, that's being used in these. All right. So, all right. Actually, you know what? I'm going to let you guys go ahead and try that. So go ahead and just try those 4 right there. Use your properties, if you use your paper right here to help you if you want, and see what's happening. All right. The first one starts, if x equals 2, then 2 times x equals 4. So think about what's changed here. We started with x equals 2, and it goes to 2 times x equals 4. All right? So go ahead and give those a try. I'm going to finish up attendance here real quick. Oh, yeah. Mm-hmm. Yes.
You're welcome.
What is happening? Oh, well, you know the solution, yes. But what I'm trying to say is, so going from this step to this step, what's changed? What happened? We start with this as our first step, and then we go to this step. What actually happened to both sides here? what did x change to be over here? What did 2 change to be over here? So how does x become 2x, or how does 2 become 4? What do you have to do to these two things to get these two things? So, yes, adding 2 to 2 would give you 4. Adding 2 to x, does that give you 2x? Not quite, right? It's not adding 2 to each side. Yeah, 2 times x gives you 2x. 2 times 2 also gives you 4. So, I mean, I can see what you were thinking. Adding 2, yeah, 2 plus 2 also gives you 4. But really, it's multiplying here because it's 2x. When you have the 2 next to x like that. So this property here is the multiplication property. Because you have to use multiplication to go from here to here. So it's the multiplication property. Okay? Does that make sense?
Yeah, thank you.
Yep. Yep. Next one. Oh, this one is... Okay, so be careful here. Symmetric just means that... Oh, these got flipped around on you. Okay, hang on a second. This is... Hopefully, I think you just flip those around. So, I think you just flip that way. So this should be, well, this should be symmetric for sure. This actually is not symmetric though, or it's not transitive either. This one is. So actually, no, so if you look here, we start with x equals 2. It then becomes 2x equals 4. So right, so, that's one way to use like substitution. I'm also saying though, the x became a 2x. What happens to x to make it 2x? What do you have to do? Right, and then same thing here, you multiply 2 by 2 and you get 4. It's multiplication property. That's the better one. Yep, you're welcome. Question? Yes. Yes, because it's so far. All right, another minute here or so, and then we'll go over these, and then we're going to jump into our last little topic for this test we're taking here on Tuesday. Okay, we have one more little thing to learn about deductive reasoning. Okay.
I love how the first two, and they're not feeling comfortable with the other ones.
Yeah, yeah. The third one I think is the most challenging one, I want to say. That's what I would say, yeah. But
Tough, then you can say that for...
And you could possibly say it for
Right,
the first one. Yeah, you could possibly say it for the first one too, yeah. So. Anyone still working on this?
Yeah, no.
Okay, we're all good? All right, so let's call on some people here. And I know, okay, we're not feeling maybe the most comfortable with this, but let's just see what we got here. So I'm going to go to... So Eli, first one there. What did you say for that property? Yeah, I'd say multiplication property is probably your best bet there. I could see some people saying substitution property here. Okay, I could see substitution, so if you put that, but I think the strongest candidate is the multiplication property. Okay, Eli, what kind of clued you in? I mean, how'd you kind of figure that out? Yeah, so if you look here, folks, right, Eli's thinking is exactly right. Starting with x equals 2, okay, and then changing to 2x equals 4, what had to happen here? Well, x became 2x, that's multiplying by 2. 2 became 4, that's multiplying by 2. And so it was a multiplication that we did there. I can also see substitution, though, because, yes, if you substitute 2 in for the x, it would become the 4 there. So I could potentially see that as well. All right? So there it is. All right. Okay. I was talking with a student as I was walking around here. The student said, maybe it's addition, because 2, if you add 2 to 2, you get 4. And that's true. 2 plus 2 gives us 4. But then x plus 2, is x plus 2 the same thing as 2 times x? Not necessarily, right? No. So, yeah, definitely multiplication here. We want both things to happen. We want to fit for both sides of the equation, not just the one. Okay. Mitchell! What about the second one here? What'd you say?
Symmetric.
Symmetric. Exactly right. And what kind of clues you in there? What gave it away to you that it was symmetric property?
Same thing, I guess.
Okay, same.
You just switch the order.
Exactly right. Yeah, symmetric property, you just switch the order of the equation. 5 equals 3a becomes 3a equals 5. Exactly right. Okay. All right, let's go to someone that's here. All right, so how about this third one here? Actually, you know what? I'm going to ask for volunteers on this one because it's so funky, I'll say. So anyone want to volunteer? What do they think for that third one there? So, Robbie?
Substitution.
You say substitution property? Yeah, I can see substitution property there. Exactly. T equals 4, then 5 times that t plus 7 equals 27. So yeah, I would say substitution property there. Substitution property. All right, and then also, how about this last one? Someone want to I'll take volunteers for this one. So Debbie, what do you okay, anyone have a different answer for that one besides transitive? What do they think? It is transitive. That's right. Good job. Okay, very good. Debbie, how'd you figure that out? How'd you know that was transitive property? What kind of gave it away to you?
Well, transitive property says A equals B and B equals C and A equals C.
Okay.
And if 9 equals 4x and 4x equals M, then 9 equals
Exactly right, okay? So again, transitive property, folks, it might not be something as simple as A equals B and B equals C, right? Here, these things are a little more complicated than just A's and B's and C's. Here we have 9 is equal to 4x. But then we're told that very same 4x is also equal to m. So 4x is not only equal to 9, but 4x also must equal m. Well, if 4x equals these two things, that means these two things must also be equal, right? They must be equal. So that's the idea about the transitive property there. All right? Questions on any of that? All right, so that's the practice with those properties here. What I'd like us to do then is to put a pause on this. So if you want, you can like take your sheets maybe and just like put them inside the book. Hold on to that. We're going to come back to those in just a second. I have a little bit of, like I said, new stuff I want to go over. Okay, so if you want to grab a piece of paper out, we'll do that and talk about those, the new things here real quick. Okay, so this is kind of like our last little, excuse me, bit of notes. Okay, and this one, I don't know, some of you guys might find this kind of fun because it's not the same kind of math you're used to, especially you like English-minded folks. So if you like really like English or language arts, right, you might enjoy. If you don't like English, well, it won't be for very long here. Okay. So we're going to talk about something called conditional statements. And conditional statements are something that you guys encounter every day of your life. They're very common in math, too. And they are kind of fundamental to writing mathematical arguments called proofs. All right? So let's kind of jump right in here. So a statement, okay, that can be written in the form put some quotes there. So a statement that can be written in the form, let me zoom in some. Okay. If ... then ... Okay. So a statement that can be written in the form if ... then ... is known as a conditional statement. Statement that can be written in the form if ... then ... is known as a conditional statement. Okay, so an easy example of that, just something you might, run across in everyday life. So you might think to yourself, if I need food, okay, if I need food, then I will go to the store. Bless you. Okay, if I need food, then I will go to the store. Ray, thank you. Okay, so I think they want you right now, Ray, and they said bring your registration form there too. Corey, it's 8:30. They want you to make sure you bring your registration form. Okay. What's that? For the people that have the passes, yeah, they want them to have that. Yep. Now, there's two parts to this conditional statement. There's the if part. Okay, the if part is called the hypothesis. The hypothesis. You've heard that word before. Okay, hypothesis. And then the second part is called the conclusion. Okay, hypothesis and conclusion. All right. Sometimes, we use symbols and stuff like that. Okay, so sometimes the hypothesis is referred to as like capital P, and the conclusion is referred to as capital Q. Okay. All right, so let's do some examples here. And so you might be wondering, how are we going to do problems with this, or do stuff with this? Well, okay, so let's do that. So for example here, we're going to identify the hypothesis, okay, and conclusion, and rewrite the statement okay, in if-then form. Okay, so identify the hypothesis and conclusion and rewrite the statement in if-then form. So that's going to be what we're going to do here. Okay. So, obviously hypothesis is the part that follows the if, conclusion is the part that follows the then. All right, so let's start out here with our first sentence. All right, so sentence number 1. If it's Shark Week, then I'm afraid to go in the ocean. Okay. If it's Shark Week, then I'm afraid to go in the ocean. That'll be our first statement there. Again, based on that, we want to identify what's the hypothesis, what's the conclusion. Can someone identify the hypothesis and conclusion of the statement without even doing anything yet? Go for it.
If the Shark Week is the hypothesis, then I'm afraid, then to the ocean.
Yep, exactly right. Yep, this piece right here, that's the hypothesis right there, right? And then that's the conclusion. Okay. Blake, is it in if-then form? Yeah, it is, right? It starts with if, gives a hypothesis, then gives a conclusion. So it's in the right form. We don't have to rewrite it. It's good to go. It's good to go. Okay. All right. So questions on any of that? That one was pretty straightforward. It's already an if-then form for us. So. All right. So number 2, let's try another one here. Number 2, my statement is, whoops. It tastes funny if you eat a clown. Okay. It tastes funny if you eat a clown. Yeah. Oh, you're going to answer? All right, let me give people a chance to write it down first. But you got it, Courtney. I'll come to you first. Okay. So it tastes funny if you eat a clown. Again, we want to identify the hypothesis and conclusion. Obviously, these are kind of like silly, nonsensical kind of statements, but you can still, obviously we'll be doing more like formal kind of like if-then things and stuff. Okay. But yeah, this is just for be entertaining. Okay. All right. So Courtney, what is the hypothesis?
It tastes funny.
So it tastes funny. How did you determine that was a hypothesis?
Because it's like the first part, and then because there's no then,
Okay.
you would just assume, because if it's the second part, that's the conclusion.
Okay, so I see what you're saying there. So we got to be careful. Sometimes the hypothesis doesn't come first. The hypothesis always follows the if. So here, if I need food, that was a hypothesis. Here, if it's Shark Week, that's a hypothesis. So with that now, what would you say a hypothesis? Exactly.
Yeah, no, that's
So what's the hypothesis statement?
if you eat a clown.
If you eat a clown, that's the hypothesis. That's right. So it's out of order. Okay. It's out of order, so that's the hypothesis now. And so what's the conclusion?
It tastes funny.
It tastes funny. Okay, exactly right. So, you better. If you come back, I'm not letting you in. Okay. So now, Courtney, since it's not in if-then form, it's kind of backwards. Can you fix it? What would be the correct order? If I put it in the if-then order, what should it start with? If what?
You eat a clown, then it tastes funny.
You got it. If you eat a clown, then it tastes funny. Okay?
Clam?
If you eat a clown,
Clam, it's clam.
it's been a clown. It was a clown. Clam makes more sense, probably. You shouldn't really be eating clowns. They wouldn't like that. Okay. If you eat a clown. Yeah, the joke, it's from a joke. It's from a joke. It's like two cannibals were eating a clown, and one turns to the other and says, "Does this taste funny to you?" That's the joke. Okay, moving on. Feel free to share that with your friends. I'm sure they'll love it. All right. Next one. Next statement here is, all dolphins are mammals. All dolphins are mammals. There's no if in here. There's no then in here. But this can be rewritten in an if-then form. You have to add a few more words, okay? Quantity, you think you got it? Yeah. All right, so what's the let's break it down first. What's the hypothesis?
If you're a dolphin.
Okay, so yeah, the dolphin, yeah, okay, so all dolphins, that's kind of like the hypothesis part here, yep. And so that makes the conclusion what?
You are a mammal.
Yeah, are mammals. And so I think you basically just said the if-then form of it, too. So yeah, that's the hypothesis, all dolphins. Okay. And then a conclusion, are mammals. But yeah, let's write that maybe more in a more appropriate, like, if-then form here. And again, you might have to, like, finesse the sentence. You might have to add a few more words into it and stuff like that. But, Kwanya, what would you say?
I said if you are a dolphin, if you are...
Yep, or you could also say, if something is a dolphin, then it is also a mammal. That's also okay, too. But, yeah, so... I'm going to say that, in fact. So if something is a dolphin, okay, then it is a mammal. So, do conditional statements have to be true? Just because I can write an if-then form, does that make it true?
No.
No. Okay? It does not. All right? And in fact, that's something you have to be careful about, because when people make these conditional statements, they put these relationships between things that might not be true in the first place. Okay? So one way a conditional statement cannot be true is if you don't fulfill the original hypothesis. So for example, if none of you guys ever eat a clown, then it will never taste funny because you've never eaten the clown in the first place. So you might not necessarily reach this conclusion if you don't have this, if you don't hit this hypothesis. But also, the relationship implied here, if you eat a clown, then it's going to taste funny. That might not be true as well, okay? So you need both. In order for the statement to kind of be true, you not only need the hypothesis, okay, but you also need the relationship between the hypothesis and conclusion to be a correct relationship, okay? So, you might eat a clown and think it tastes delicious. So, Anyway. All right, let me give you one to try. Here's for you. So again, identify the hypothesis and conclusion, and then rewrite it in appropriate if-then form if necessary. All right. I'll go to Chipotle if I have the money. Yeah, I know. I feel like I wrote this like a semester ago, and now I'm like, I wonder if people even go there now. So anyway, I'll go to Chipotle if I have the money. So again, identify the hypothesis, identify the conclusion. Okay. Yes, and then so you want to now write it in the correct order. Rewrite the sentence in the correct order. So again, once you guys have it done, rewrite the sentence in the correct order, please. Rewrite the sentence in the correct order. Question? Yeah. Yeah, if you have it, yep. All right, let's go to, all right, column S. Column, so what is the hypothesis in the statement here? Yeah, well, Chipotle is not the hypothesis. It is the first statement, but remember, the hypothesis always is the part that starts with the if. So what's the hypothesis then? If I have the money, okay, and so what's the conclusion then? I'll go to Chipotle. So in a correct if-then form, I should just have if what? If I have the money, the money, then what? Then I will go to Chipotle. Right. Hopefully not. Okay. So this was the conclusion. It started out first, and then this was the hypothesis. Okay, tomorrow for our warm-up, you'll see how a lot of advertising companies use these statements to kind of like, I guess, to like help sell their product to you, okay? So if I go to Chipotle, I'll go to Chipotle if I have the money. I want to talk about one more thing here. I'm just going to squeeze it in here right at the bottom. I want to talk about the word, what a converse is. We're going to see this show up, okay? A converse. Now, you guys know Converse is, right? Shoes, right? Okay. Shoe company. But a converse actually originally came from these logic statements, okay? So if we start with, if I have the money, then I'll go to Chipotle, okay? That's the original statement. We'll call that. The converse of that statement is if you take the conclusion and make it the hypothesis, and take the hypothesis and make it the conclusion. So in other words, right now, in if-then form, I have, if I have the money, then I'll go to Chipotle, okay? The converse of that statement is, if I will go to Chipotle, then I have the money, okay? You'll notice the meaning changes a little bit when you do something like that. Or, you know, if something is a mammal, then it is a dolphin. Now let me talk about that, right? So that's the converse, right? If something is a mammal, then it is a dolphin. So the original statement, if something is a dolphin, then it's a mammal. Is that a true statement? Yeah. If you're a dolphin, you're a mammal, right? Dolphins are mammals, okay? But now we do the converse of that. If something's a mammal, then it is a dolphin. Is that a true statement? Yeah. No, not necessarily, right? So, just because the original statement's true doesn't necessarily mean the converse is true. They're kind of separate things. Sometimes they will be true, sometimes they will not be true, okay? So, the converse flips the order of the statement. Flips the order of the statement. Okay? Yeah. That's the only thing we're going to... And that we'll see those later on, okay? I'm not going to, like, test you on them necessarily, but, I mean, we'll see those later on. Okay? So, if you would please get your books back out real quick. I have a few more that I want to look at there, and I'll give you guys your assignment. So, page 47, back to page 47... Okay, back to page 47. Got some pictures of some zebras there. It's a pretty impressive reflection that they have going on there in their water. It looks like there's 6 of them. Nice symmetry there. Oh, there's 4 there?
Yeah.
Oh my goodness, you're right. There are 4 there.
The third one looks like it's bigger than all the others, but there's only...
Yeah, exactly. You're right. Because the stripes even like line up almost with them. So, all right. So number 3, it says to write each statement as a conditional statement. That means in if-then form. Okay. So volunteer for number 3 there. We have all zebras belong to the genus Acus. So how can we swap that around? Let's go to court. Let's go to court.
If you were a zebra, you belong to the genus whatever.
Acus. Yeah, okay. So if you are a zebra, then you belong to the genus Acus. Okay, if you guys have you guys taken biology yet? Yeah, so you guys talk about like how you classify groups of animals, right, and stuff like that. There's like the kingdom, the phylum, and all that good stuff, you know, whatever. So that's one of their, I don't know what, you know, which name that is, but anyway, Acus. Okay, have you guys seen this? Like, this shows up in other words. What's that? It's Latin. Okay, that's right. What's it Latin for? Yeah, it's Latin for horse. Okay, so for example, if you do, did you take Latin? Okay, me too. So it's a dead language, but you know. Anyway, so but it shows up in English a lot. So for example, if you like to do sporting events with horses, you are an equestrian. Okay, like that's like equestrian events. Those are horse events, right? So stuff like that. Okay. Anyway, next one, number 4. So again, in if-then form, that we have the original statement here, the bill will pass if it gets 2/3 of the vote in the Senate. What should it be, Antoinette, there, in correct if-then form, or in normal if-then form?
If it gets 2/3 of the vote in the Senate.
Very good, exactly right. If it gets 2/3 of the vote in the Senate, the bill will pass. Okay. Okay. If it gets 2/3 of the vote in the Senate, the bill will pass. Alright. Questions on any of that?
What's number 5? Is it part of like?
Number 5, I think, is it's a separate set of directions from 3 and 4. I think 5 is like the number 6, I think. Tristan. So it's like, I think they actually want you to solve the equation, and then give the reason for each one. I'm not going to have you guys do that, though, so don't worry about that one. Okay? What I'm going to give you guys now is your assignment here, okay? If you look here, this is kind of a weird section of the book. They also have, for example, angle addition postulate problems right here. So, for example, you guys remember this, where we had 2 pieces of a segment, and they add up to be the full segment. So there they did RS plus ST equals RT. Combine like terms, solve for X, get X is 6. Here they did the same thing with an angle, where they have 2 angles. You can add those 2 up to get the big angle RST, which is a measure of 15x minus 10. Set up the equation and solve. So there's going to be a little bit of review in this assignment tonight, too. You'll see there's also like point finds and planes talked about in here. So we're going to hit a couple different things tonight for the assignment, so just bear that in mind, okay? So, all right, for your assignment tonight, I would like you to, let's see here. We're going to start on page 54. So if you want to turn to page 54 there, okay, I'm going to give you some of these hypothesis and conclusion statements. So 13, 14, 15, and 16. Okay, you can see some of them are already in if-then form, some are not. It just says to identify the hypothesis and conclusion. All right, and then for some additional kind of practice and, you know, kind of getting us ready for this test, I'm going to give you some of these kind of like review-ish or style questions, okay? So I'm going to give you, let's see here, 17, 18, and 19, and 20, why not? Okay, do that one. And then 21 and 22. Okay, so basically 13 to 22 is what I'm going to give you guys for your assignment. Okay, 13 to 22. You will need to draw a picture for 17 to 20. I'm just going to write it in here right now. Draw a picture! Exclamation point.
Can you use like different, like if we use a different piece of paper for it?
Yeah, if you want to use a different piece of paper, that's fine. Absolutely.